The other special products we'll look at in this section deal with the sum and difference of cubes. So it will look like a cubed plus b cubed, or for the sum, or a cubed minus b cubed. Well, and it might not be as nice as just a and b. There might be numbers and letters. Like if you look at problem 40, there's 40x cubed and 135 y to the 6. We just have to figure, so a is more than just one thing. But first let's talk about how to factor these, and then we'll apply that to these two problems at the bottom of the page. So they have the same terms, it's just that the signs are different in the two formulas. The first set of parentheses is always going to have the same term as the problem to begin with. And actually, before I do this, I just want to remind you, we can factor the sum of cubes, but we cannot factor the sum of squares. If you had a squared plus b squared, that's prime. You can't factor it. You can factor the sum of cubes, and I'll show you how to factor it, and then we can check it to make sure that that's right. Okay, now back to what I was saying. The first set of parentheses always has the same sign as in the initial problem. So if it starts out as the sum, the first set of parentheses has a sum. If it starts out as a difference, the first set of parentheses has a difference. And then the terms are the same. It's just, you kind of ask yourself, what's the cube root? So what do you cube to get a cubed? Or what's the cube root of a cubed? We'll talk more about cube roots later, but that would just be the a. What do you multiply by itself 3 times to get that? And then this is also a, and then what do you multiply by itself 3 times to get b cubed? Well, that would just be b. Now to fill in the second set of parentheses, the second set of parentheses has 3 terms. And there's kind of a nice little pattern. So I always think of, okay, once we're done with the first set of parentheses has a first term and a second term. And so the second set of parentheses, whether it's sum or difference of cubes, it's always first times first, and then first times second, and then second times second. Okay, so you kind of make all possible pairs. First times first, first times second, second times second. Okay, so let's think. If you did first times first, if you did a times a, that's a squared. And that's the same for both of them. And then first times second, first times second would be a times b, and that's for both of them. And then second times second, so b times b. That's just b squared. And that's the same for both of them. Okay, so we have to figure out what the signs are in the second set of parentheses. So I'm going to focus on the one at the end. And I know that when I multiply everything out, what I want my last term to be is positive b cubed. Well, the only way I can get b cubed is doing the b times the b squared. And if the b is positive, then this has to be positive. Positive times positive makes positive. And here, now this one is negative, and I want the answer to be negative. So I can't put a negative here because then negative times negative would be positive. So I would get positive b cubed. So this one has to be a plus. So both of them end in plus b squared. And then the middle term, so what I figure out for the middle term is the whole problem, whether it's sum or difference of cubes, should always only have one minus in the whole factored form. And this one already has a minus. So everything else has to be plus. This one has 2 pluses. It doesn't have a minus yet, so that one is a minus. Okay. So now I just want to show you that I'm going to verify this top formula. So let's multiply out a plus b times a squared minus ab plus b squared. And then I want to show you that we get back just a cubed plus b cubed. So this is more than just FOIL because it's not just outside and inside terms. You have this extra middle term there. So what I'm going to do is first distribute the a to all three terms of the second set, and then I'll distribute the b to all three terms of the second set, and we'll write what we get. So a times a squared gives us a cubed. A times negative ab, well, positive times negative is negative. A times a is a squared, so we have a squared b. And then a times positive b squared, so positive times positive is positive, and then that's just ab squared. Okay, so now I've done the a to all three terms. Now I want to do the b. So b times a squared. So you could write b a squared, but remember, it doesn't matter what order you multiply in. So I'm going to put the a's first, just so they're in alphabetical order. So it would be the a is squared and then b. And now the b times the second term. So positive times negative is negative. B times ab. So there's just one a, but the b is going to be squared then. B times b is b squared. And then the b times the b squared. They're both positive, so it's plus. And b times b squared is b cubed. And now we want to look for like terms. Well, there's only one a cubed, so that just stays there. And here's a minus a squared b, and here's a plus a squared b, so they cancel. And here's a plus ab squared, but then there's a minus ab squared, so they're going to cancel. And then we just have plus b cubed left at the end. So that shows that that way of factoring worked. Now some of the WebAssign problems might say factor completely, and we saw in some of the difference of squares problems that maybe even after you factor once, one of the parentheses will factor even more. These second set of parentheses, you can never factor those anymore. So this part will never factor. So you don't have to worry about trying to, when there are numbers, finding any that work. And I'll show you with one of the examples we do down here at the bottom of the page. Okay, so first I'll do problem 58 from the book. So I just see two terms, so it's a binomial, so it's either sum or difference of cubes, or the only thing we can factor with squares is difference of squares. So the thing is, I see an x cubed, so that makes me think it's probably the sum, and there's a plus, so I think probably sum of cubes, but 40 is not a cube. If you start looking at cubing numbers, 1 cubed is just 1. 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. So we skipped over 40, so that's not a cube. So then we ask, oh, is there something I can factor out first? Well, this ends in a 0 and that one ends in a 5, so they have a 5 in common, so we should factor that out first. So if I take out the 5, then 5 goes into 48 times. So we have 8x cubed plus, and then you can do this on your calculator. 5 goes into 13 twice. With the 3 left over, it goes into 35 7 times. Y to the 6. You should also ask yourself if they have any variables in common. But this one only has x's and that one only has y's, so I can't take out a variable. Well, now this is the 8 is a cube. I see that in my list, and so is 27. So I know this is probably going to be able to be factored as the sum of cubes. The 5 still stays out in front. So I ask myself, okay, what do I multiply by itself 3 times to get 8? And that's 2. So the first term is 2 and then x. So if you did 2x times 2x times 2x, that would give you 8x cubed. This starts out with a plus, so my first parentheses has a plus. And then 3 times 3 times 3 is 27. And then you have to ask yourself, oh, well, how do I get y to the 6th? Well, I'd want something cubed to equal y to the 6th, and that would have to be, using our rules of exponents, that would have to be y squared. Oops, sorry. Because here, remember, we multiply exponents when it's written like this. 2 times 3 is 6. So I must need a 3y squared here to get that 27y to the 6 if I multiply 3 times. Okay, so now we're ready to fill in the second set of parentheses. And so remember the pattern. First times first. 2x times 2x is 4x squared. First times second, so 2x times 3y squared. And then second times second. So 3y squared times 3y squared is 9y to the 4th. I'm going to worry about signs, and then we can't leave the middle term like that. We have to write it so that it looks nicer. So remember, I want a positive 27, so that has to be positive 3 times positive 9. The last sign is plus. And then once I'm done factoring, I should have 1 minus in the problem, and I don't have one yet, so it must go there. So now let's write it a little nicer. So 5 times 2x plus 3y squared, and then 4x squared, 2 times 3 is 6, xy squared, plus 9y to the 4th. And then that's our answer. Okay, and last one for the section, 87 from page 409 still. Okay, so I see some y cubes there. And actually, both terms have a y cube, so I might as well factor that out. But this one has an x, and so does that one. So I can also take out an x. And then I should say what's left in each term after I factor out xy cubed. So the y cubed is gone. And if I take out an x, and I originally had 4 of them, then x cubed is left. Plus, so the 216 is still there. And then the x is gone and the y cubed is gone. So that's just it. Oh, I'm sorry. I wanted to go back and talk about that why, or to show you that there's no way we could factor this second set of parentheses. And I'm going to think about using that AC method. So remember, if you think of this as, you know, the A, the B, and the C, so our numbers are 4, 6, and 9. A times C is 36. And then we would try to find factors of 36, and they would have to both be negative, since the middle term is negative, but the last one is positive. So we want terms that add up to -6. So we want factors of 36 that are both negative that add up to 36. I mean, that add up to -6, I'm sorry. Okay, so all of the ways to factor 36 with 2 negatives are -1 and -36, -2 and -18, -3 and -12, -4, -9, -6 and -6. And if you add these up, you get -37, -20, -15, -13, and -12. There's no way to get -6, so you can't factor that last set of parentheses. Okay, so here I'm thinking this one is probably the sum of cubes too. I just don't know what I'm going to use for 216 yet. So let's see, I'm just going to continue in my list, and you can do this with your calculator, but 5 cubed. So I think 5 times 5 is 25, and then times 5 again. So whenever I have 25, I think of money. So if I had 5 quarters, so that would be 5 times 25, that'd be $1.25. So 125. So that's not right. And then 6 cubed. Well, 6 times 6 is 36. And again, you can check this with your calculator. If you do 36 times 6, that's 216. So now we know what we multiply by itself 3 times to get the 216. So let's see. xy cubed times, okay, since this now we know is the sum of cubes, we can use that formula. So it's just going to start with x. The original sign was plus, so this has a plus. And then it was 6 cubed that gave us 216. And now we have to fill in the second set of parentheses. So first times first, x times x is x squared. First times second, x times 6 is just 6x. Second times second, So 6 times 6 is 36. I want positive 216, so it has to be positive 6 times positive 36. And I don't have a negative yet, so the negative must go here. And that's the answer. All right, so that's it for 6-4.